latex printers have added a bit of a wrinkle to the adage of speed, temperature, and ink load. Now, speed, temperature, ink load is still valid. All prints are affected by the speed that they come through the dwell time, the temperature that the media can take, and then how much ink you can put down on it based on those first two things. And again, I'm going to go speed, temperature, ink load because that's the key principle of printing. However, we have a new wrinkle, and that is Optimizer. Now, you've probably read quite a bit about Optimizer and you've had it presented to you. I want to make clear how the Optimizer works in a real practical function. Now it's speed, temperature, ink load, and Optimizer. Because Optimizer is one more knob that you have which you can use to control and affect the evaporative process that traditionally on a latex could be the point at which it affects how fast you can go and how much ink you can put down. Essentially, the Optimizer is a positively charged solution. I'll put it in kind of simple terms. And the inks are negatively charged, and they're attracted to one another. The Optimizer has its own print head. The Optimizer is treated just like an ink. And that print head is out a little bit in front of the other print heads. And the Optimizer, which is a mostly invisible film, it's a solution, goes down onto the material first. The ink is attracted to that Optimizer. That is, the Optimizer brings that ink and fixes it to a point. It prevents the ink from migrating and bleeding and coalescing. In effect, the Optimizer replaces the evaporative process at the print point. And that's a big difference between our previous latex printers. The previous latex printers had a heater right here. This wasn't clear. That heater was fundamentally evaporative. You had to take a certain amount of the water out of the delivery vehicle so that you had the pigment and the latex remaining. If you did not take enough of the water out, you would have image quality problems. It would bleed or coalesce. Those were the issues that you faced on the previous latex printers. So your choice is always, slow it down or put less ink on. Now what I can do is I can increase the Optimizer a little bit, and the Optimizer fixes the drops so that they can't move around. The ink in this print path here has much more water on it. There's really no evaporation taking place back there. The Optimizer is holding everything together. All of the evaporation and the activation of the latex component is all happening in one zone, the curing zone. So the old drying, or probably better put, evaporation zone isn't on the printer anymore. The Optimizer is giving us better color with more even results, edge to edge and end to end, and it's doing so at higher speeds. We changed the chemistry of the ink entirely so that we could address speed issues and color consistency by marrying ink to an Optimizer and having that natural chemical attraction allow everything to print a nice smooth surface. So let me show you some of the practical effects of Optimizer and the way it works and the way it influences the key charts that allow you to interpret speed, temperature, and ink load. So there's a first chart that you print, which you can print with any new media. Our engineers on this particular printer were ingenious in developing this chart. So if you create a new media on any of the latex printers, you say, I want to build a new media. And then it asks you, what kind of media? And you tell it, say, banner. This is an 18-ounce scrim banner. So then in the banner is there, and it starts at 8 pass. It gives you a recommendation. Now you can change that, but it starts at some point. It also has a default Optimizer setting associated with it. In this case, it was 12. For most smooth surfaces, including banners, 12 is generally speaking the right Optimizer setting. You don't have to put less, you don't have to put more. You will get the maximum effect of the Optimizer at 12. Some other materials like fabrics, it's going to be 24. Canvases can start at 30, and I've seen them go as high as 47. 47 is the highest I've ever seen an Optimizer setting, and that is for a particular type of canvas that has a very rough and uneven surface to it. We're using more Optimizer to hold the drop so they cannot sort of filter or sink down into the valleys, and then instead they stay on the mountaintop of the canvas. It prevents the sort of flecking and white flecking that happens when the ink sinks down and then the tips of the material are showing through. What you want is a nice even tone. So when this chart is printed, and I can look at it right now and tell you what pass it is because it only goes to 100%. 100% is indicative of 8 pass and 6 pass. So I already know pretty much what pass mode this probably is. If it were 10 or 12 pass, it would go up to 120% density. We changed the available density a little bit based on the likelihood of it ever having any chance of curing at a certain speed. So we already kind of know that on a banner, you're not going to get better than 100% at 8 pass, or we don't recommend it. Now, when you print this chart and you choose 8 pass, the optimizer by default in the Advanced tab is set for 12. If you disagree with that, there are some ways to determine whether you think you need more or less optimizer. A canvas that might have a very irregular surface or a real dimpled surface might benefit from a little more optimizer. And there's a way I'll show you in a second how to check for that. So this chart was printed at the regular settings with the normal optimizer. What it's showing here is at, let's say we did this at 230 degrees Fahrenheit at 8 pass. You have 3 things in play: bleed, coalescence, and think of coalescence as like bleeding within a color. Usually coalescence, when things aren't quite right, it's going to show up with almost like a fish-eyed look, like you're seeing things with underwater goggles. You know, the ink, the water in the ink is hitting the material and it's kind of moving out on you before you can fix it. Instead of a nice smooth tone, you get this irregular tone to it, and that's coalescence. And then lastly here, what you have is the global ink limit. It is, in a sense, the maximum amount of ink you'd ever be likely to be putting on the print. So somewhere in your files, some customer is going to give you a job that has an enormous amount of what we would call rich black. When that rich black goes through the printer, you need to make sure that you have the settings so that everything is completely cured. If you're putting too much ink on it, it will not completely cure, and you'll get this hazing or greasiness. That is common when you have too fast a speed, too low a temperature, and too much ink. One of the things that's a real virtue of this chart is, and why it's so ingenious, is it's allowing the end user to determine how much ink you can put down at a certain speed, at a certain temperature, and then know that every print you send through it will be dry. It will be completely ready to go and finished. And this chart is the first chart. It is a visual chart. So in this case, I can see there's some hazing at 100%. I can see traces of the hazing at 90%. Sometimes the hazing will show up here or on the edges, but it'll usually have a little greasiness to it and a little irregularity to the surface. On an adhesive vinyl, it's very obvious that it's not dry. That's what this means, is can I put the max amount of ink using 100% density on this banner? And the answer is no, you can't. You're either going to have to slow it down or turn up the temperature. Now, because this banner is thick, generally you're going to have to turn up the temperature if you want to have more ink down, if you want to get to 100% density. Your other option is 80. So 80% density is pretty much dry, and there's no hazing, there's no coalescence, and there's no bleed. So 80% at the choice I've made at the speed and the temperature would be the right decision to make. Now let me show you a chart. This is, in a nutshell, speed, temperature, and ink load right out of the gate. It's the first thing you're going to do. And once you determine that, you're kind of home free. If you did nothing else past that point except choose those, at the very least you would have a print in which the category would choose a color calibration for you automatically, and it would also choose an ICC profile based on the category automatically. And you would get pretty good results right there. Because what we're doing is determining speed, temperature, and ink load, and those are the core cornerstones of printing on a latex printer. Now we've added an optimizer, which changes things a little bit. So this is the second chart I want you to see. Down it goes. This is the same chart, but with no optimizer. Now that's sort of an extreme take on it, but I want it to be really clear what happens when you take away the role of the optimizer on these new printers, or you don't have enough optimizer. What happens is it is just bleeding and coalescing all over the place. The bleed is terrible, the coalescence is off the charts, and this global black is both wet and irregular. Without an optimizer, this looks a mess, and this is unsaleable. As soon as I go to 12, everything smooths out. Now there's another chart, which I'll show you in a moment, which will change it to say 24 and see if more optimizer will help or if there's no change. We'll also show you what it will look like with less optimizer. Sometimes what I'll do is I will run this initial chart with different optimizer levels. I will put those prints up in a light box, and if 12 looks no different than 18 or 24, then 12 is the right number. But if I go to 8, and generally I don't go under 12 for anything, you go down to 8, you start to see it bleed and migrate, then you go back up to 12. There's always a sweet spot for optimizer, and you don't want to put too much. You can get away with putting a little more optimizer, but it's just adding liquidity and it's not giving you any additional benefits. So you want to get kind of the right amount of optimizer. But this is a very good indication of how important optimizer is and the role it plays in allowing the printer to print faster speeds with perfect even tone color by using the optimizer to fix the ink. It's overcoming the limitations of evaporation, basically. Now here's another chart of the exact same thing, but this one is on canvas. Now the reason I brought this up is because there's one area in the printer where the settings are not quite right. Generally speaking, they're all pretty accurate. You can load a material, choose a category, and it will get the right optimizer for you. The only one that's a little bit questionable is if you choose canvas, the path we're recommending is you go into textile and it's coated textile and canvas. If you choose that category, the default optimizer number will be 12. 12 is, in my opinion, too low for canvas. Canvas should be 24, mostly I run 30. If you look at the media locator and you go through the baseline settings for most of the canvases, you'll see that most of them are 30, and in some extreme cases even more than 30. But 30 is a good place to start on canvas. 12 is too low. 12 is inappropriate for canvas. And the chart shows you, don't let me tell you, let the chart do the talking. Because if you print, in this case at 12 pass, and you put 12% optimizer down, what you'll see, and certainly what I saw, is you have very noticeable bleed and coalescence, but the bleed is very clear. So normally what you have to do in that case is, on a previous latex generation, I would have to go in and slow it down because I need this ink for canvas. I want a rich, deep, saturated print. I don't want to reduce the ink on a canvas. Canvas has to have that color pop. So I need 110 or 120, or in some cases even more, 130% ink. And I don't want to have to go all the way back to 80 or 90 because that's where the bleeding stops when I run 12 optimizer. So these settings are not going to work at 12. But now with the optimizer, you run the exact same chart, but you turn the optimizer to 30, and presto, all the bleeding is gone. Everything smooths out, and you can run higher ink loads with deeper density. You're going to have a richer, deeper color. Your Pantones are going to be deeper. You're just going to have a better canvas print at 110 or 120 than you're going to have having it print back at 70, 80, or 90. And that's really important because the optimizer is doing that role. And hopefully we can catch these two differences, particularly in the bleed area. So that's the one setting in there I want you to be aware of. But this illustrates the effect of that optimizer and what the optimizer is doing. Now this is a chart that's actually on the image quality tab on the printer. It is under Print Latex Optimizer Check Plot. So if you wonder, do I have the right amount of optimizer? You print this chart. And this chart is going to show you where you're at where less optimizer will be and where more optimizer will be. You can use this chart, or you can go into the settings and change the optimizer and run this calibration chart. I usually use the calibration chart. I'll do a couple variations and look very closely at the bleed and look very closely at the coalescence, and that usually tells me everything I need to know. If they look the same, I go with the lesser amount of optimizer. Using crazy amounts of optimizer like 70 or 80%, that's not giving you any benefit. It's wasting optimizer, and in some cases, the effect of too much optimizer can be deleterious. It creates problems rather than solve problems. There's a sweet spot for optimizer, and we have several ways to get there to try to find it, and this is certainly one of the charts to do it. So hopefully that explains how optimizer works, at least gives you kind of a working understanding of it and what its role is, because the optimizer is a very important development in this printer. It is the key technological advance that separates this new generation printers, I believe, from the previous generation of printers, because it really does replace the evaporative process with a chemical attraction process, and it's given us a lot of improvements, both in the color consistency and also in our productive speeds.